ever opened Netflix just to watch one episode of any TV show and suddenly 4 hours disappear? I hope that this happens eventually with everyone. And today we will be working with Netflix based data to understand that why usually we are so much focused towards the content available on Netflix. Do they randomly provide that content for us? Or is there any strategy which is there inside that? Yes, there is a lot of data science which is available in the EDA portion when we will work on this Netflix based data you will analyze. So, I have taken a data set from a Kaggle based platform. It's a public data set available over there. We will discuss firstly that, what exactly the number of columns we have and what's the meaning of each and every column. And after that, we will try to clean our data wherever required. At the very end, you will observe that there is a lot of insights which we will be able to gain after creating univariate analysis and bivariate analysis corresponding to it. So, without wasting any time, let's get started. Okay, so now I hope that my screen is properly visible to everyone. So, over here, before we will start and deep dive into the charts and the visuals, it's very important to understand the given data. Then only we will be able to get a better insights of it. I hope that we all are aware about the complete flow of any life cycle of any ML project. So over here, let's assume that data is something which is available to us. So in terms of data collection, you can assume that it is already being available to you by the clients. For now, we are taking a data from a Kaggle. So I will showcase you it's a public data which we will analyze today, right? With the name of Netflix titles. So over here, I have fetched the data from here. You can see the given file. And over here, these are the columns we have: show ID, type, title, director, cast, country, date added, release year, rating, duration. Now, it's very important to get the intuition about each and every column that we will be having. Over here, although it is mentioned that, you know, uh, we do not have a description yet, but I think it's quite intuitive to understand that what exactly each and every column indicates to us. When we talk about show ID, you can consider it as a unique identifier for every specific record, for every specific content item which we have on Netflix in a given available data. So you can consider it as a primary key. In SQL, usually we learned about this primary key, which is kind of a unique identifier for any given specific record. So show ID, you can see it is 8807 unique values available to us, which somehow indicates the unique records in a given table. Then we have a type. Now you will observe that over here in Netflix, we do have two type of content. We can say that one is movie based content, another one is TV show based content. And they have mentioned that in this specific data, almost 70% of the content is by movie and remaining 30% is by TV show. After that, we will be having the title. Title is something which itself indicates the meaning of it, name of the content you can consider. So we will be having 880 unique values. So it seems that there are no missing values available, at least in title specific column. Then we will be having a director. Over here, director is the name of the director in any given record. And they are saying to us that they have 30% almost null values. We will see when we will analyze as well. And let's try to see that how can we handle that also. Then we will be having cast. Now, cast means that who are the exact actors involved in a given movie or in a given TV show. And over here, again, I can see that they have mentioned 9% missing values are available. Okay. Then the country is another column that we will be having, means the country of origin. We can say that US and India are the given options that we will be having in this specific data. Then date added is the another column. It means that when exactly the Netflix added that specific content to their platform. Release year, what is the release year of that movie or that TV show. Then we have the overall rating. Now this rating indicates the audience maturity level. Okay, we will discuss in our demonstration that what are the different classes of maturity level we have in this given data. But as we can see that there are maybe three classes they're talking about: TVMA, 1 4, and other classes are there. Finally, the last column indicates the duration of the movie. Now, in this duration, obviously there will be one season, two season, and others uh, they are providing to us. It could be in the minutes, but we will see at the time of demonstration, at the time of EDA, what exactly they are showcasing to us. It should be ideally in minutes, but we can see if it is in hours or in seconds as well. So we will see what is the duration of a movie, what is the duration of a season. Okay, and if it is a season, it could be one season, two seasons, three seasons, and so on. So basically this is the type of a data that we will be having. Now with the help of this data, we have to analyze that whenever we will see any content on Netflix, is this something which randomly came up, or is this something which is planned and evaluate by data analyst, data scientist, and from that recommendations only we will be able to get the new TV shows or the movies. So let's do the proper analysis of it. And definitely it's not random. Right now, everything, whatever we see on any of the social media platform, it is properly planned by data analysts, data scientists. They have completely observed their data, do a recommendations, predictions based on a given algorithm. So let's try to analyze it one by one and let's try to find the insights on top of it. So over here, I will go back to the file, and whatever be the steps that we have done, let's try to analyze it and let's try to do on top of it if required, right? The very first step is quite simple. That is the usual step that we usually do, which is to load the required libraries. So what we are doing over here, that whatever be the important modules which are required in a given implementation, majorly they are pandas for for the data manipulation task, numpy for the numerical calculation part, matplotlib and seaborn for the visuals part, and I am using over here word cloud as well. We will see that this specific library is being very helpful to showcase the unique words in a given Netflix data. We'll try to demonstrate that as well. Now, let's try to do the very first task, which is about we will try to load the data. Now, when we talk about data, just now we have seen that how exactly this data looks like. So over here, we have just mentioned the path. So what we have done over here, that we have directly loaded the specific data. Let me connect it again and I will try to showcase you what exactly we have done. We do have two options. Either we can try to upload our file directly in the collab, or maybe we can directly connect our Google Drive in the collab. So you have an option of mounting a drive with the help of which you can directly write a path of your G drive where your data is available. Now, let me try to run it side by side, and this is done. We will be able to load our data. And again, these are the columns that we have. Already we have discussed about all of these columns. Okay, we do have another two columns. These columns are, okay, so over here in the visibility part, 10 of 12 columns are visible, but the remaining two columns are listed in and description. I hope it is also visible to everyone. So what exactly as a part of Netflix it is being listed in, maybe documentary, maybe TV show, maybe drama, and so on, and the description of that specific content. So all of these columns that we will be having. Okay, now let's move ahead. And obviously, if I want to get the complete information or the summary of my data frame, so we know that we have an info function corresponding to it in a data frame. So we can get a complete summary of the data frame, right? So we can use netflixdf.info to get that. Now over here we are observing that only one of the type is numeric, which is the release year. Apart from this, remaining columns have the object D type. Now, few of them still make sense to me. For example, if I'm seeing title as an object type, it makes sense to me. I'm seeing cast as an object type. It makes sense to me. Country as the object type, it makes sense to me. But there are few columns, for example, date added. It's of object type. Does it make sense? No. Because ideally, when we talk about date added, it should be of date time type, right? So obviously, we can write one section of insights over here, and maybe we can work on these insights later on when we will be doing the actual data cleaning step. So we have observed, first of all, that in total we will be having 880107 entries. It means that many number of records are there. Now, any specific column which is having less than 8807 entries, it means that somehow that specific column contains null values. So can I say that in total we have we have 8807 entities. Now, any column which contains less than that, any column which contains less than, we can mention 8807 entities, contains missing values, and we will have to work on it. So majorly, what are those specific columns? We can list it down. It is director. I'm writing it over here. After that, I can see caste. So we have to handle this also. We have country. We have to handle this as well. Then what else we have? Uh, Date added is also a part of it. Okay. What else we have? So over here, release year is fine. Rating duration is also a part of it, although the percentage of missing values in these specific columns is really low. So we can think about it, that how can we handle it in a later strategies. But yeah, these are the columns that I have listed, which contains missing values: director, caste, country, date added, rating, and duration. Perfect. What's the next insight? We have observed a data type inconsistency. Inconsistency in date underscore added column. Ideally, it should be of date time type, but currently it is of object type. So we have to tackle that specific issue as well. In the next specific part, any other thing which we can observe when we talk about the attributes or the number of columns. So we have observed that the number of features, columns, whatever you can say, it is equivalent to 11. So these are the not 11, 12, sorry, 12 features we have, starting from 0th index, which contains show ID, till the 11th index, which contains description. Perfect. These are the insights that we will be having. Now, let's go further. What we have done till so far is we have understood the data well. That's the only thing we have done. So in terms of data understanding, we have figured out that what exactly is the meaning of each feature, how many number of features we have. So we have seen that the shape of this data is 8807 number of records and 12 unique columns we have. Plus, we have also seen the meaning of each column, each specific feature. After this, we have also gained the insights with respect to the issues which we have in a given data, whether we talk about the missing values or we talk about a data type inconsistency. Perfect. Now I think it's the right time that we should go to the next step, where what we will do is we will try to handle the uh, data cleaning part and make sure that these issues won't be there. So let's do a data cleaning and transformation part. So we will clean the data and we will try to transform the columns. So let's start working on it. I hope that till so far everything is clear to everyone. So let's move ahead to the next step, where what we will do is we will do data cleaning, and what we can do is transformation. Now over here, the very first step will be, which is a very critical step, is to check the exact count of the missing values, which we can do using is null dot sum. Is null is actually a boolean function which will either return me the result as either true or false, and then I am on top of it writing dot sum, which will give me the total count of missing values with respect to each and every column. Although we know that from the above intuition that what are the columns involved in missing values, but exact count is very important to evaluate, so that we will be able to understand that how much is the percentage of missing values we have in every column. So we can see, as we have mentioned in the above part, in the insights part, director is the one which contains very huge quantity of missing values, followed by caste, country, and then we have date added, rating, duration, which contains somehow missing values, but the number of missing values in these specific columns at least is very very low. Now the point is that usually in stats we apply a very simple intuition whenever we try to handle the missing values. I hope that you must have heard about it, that when the percentage of missing values is very less, missing values is very less. For example, it could be less than 5%, less than 3 to 5%, you can say. In that specific context, better idea is to drop those specific records. So we can drop the records which contains the missing values, right? Because we don't want to do heavy computations also, and we want the training to be faster but with a cleaner set of records. But every time dropping the records is not a good idea, because maximum number of times the chances are very high that the percentage of missing values is quite huge. And if it is quite huge, and if you will think about dropping those specific records, that's a trouble, because in that context you will lose the information. So the better idea could be, in that context you will do a data imputation, right? You can do a data imputation. Now it depends on what specific data you have, then only you will do the imputation. Imputation meaning that you are trying to replace the missing values with the actual evaluated value, right? For example, you can impute it with the mean or median, you can impute it via mode. It depends on what type of data you have. Usually I categorize data into two components. It could be the case that your data belongs to a numeric type. Now in numeric type I can consider int, float, whatever the type we have. And in that context, better idea is to impute it either mean, with either mean or median. But if you don't want to take any risk, you don't want to replace it with the wrong number, even if the outliers are there, you want to handle them pretty well. So median is a good idea, because median is a more robust measure to outlier. But when we talk about a categorical data or a object type, right, or a object type data, so in that context we cannot evaluate mean or median. That doesn't make sense. In that context, evaluation of mode and doing an imputation with mode will make more sense, right? I hope you guys agree with me. Another strategy which right now many data scientist people follow is they can do a imputation by applying the machine learning algorithm itself. There is a very famous technique called as KNN imputer. So KNN is a supervised learning technique, and what it does is it will try to apply a KNN algorithm on a given training set, and it will try to give us the idea that what could be the best prediction, best number which we can replace with. So it's kind of, you can apply a machine learning algorithm, and that algorithm is giving a prediction based on that training set, based on already available data points, that what could be the best value we can impute with. That is also a nice approach, but obviously it will be computationally heavy as comparable to the above approach, because computation wise, if you compute mean or median, or let's say mode, it is quite easy job as comparable to applying a ML algorithm itself. For now, we will be focusing towards doing this kind of a imputation, but maybe in the future projects, I might use the below approach as well, so that you will have a gist of both the approaches. Perfect. Now, let's go back and let's try to understand that which specific fields we can consider that we can handle with a dropping part, and which specific fields required a proper imputation. If we have to think, maybe duration rating is quite lesser, we can drop it. But when we talk about director, we talk about caste, we talk about country, we have to do the proper imputation of it because the percentage is quite huge. So let's get started. Now, what we can do is we can first of all try to handle the two columns, which is director and caste. Now, intuitively, when we talk about these two columns, I told you that when the data type is object or categorical type, we can impute with mode because mode brings the maximum frequency of a given record in a given entire column. But when we talk about director and cast, we cannot impute it directly with which specific movies have a maximum director, meaning same director. And the frequency of a director, let's say, is higher in one specific name X. So we can impute it for other specific shows as well. It's not a right approach because we don't want to impute with the wrong number as well. So better idea could be in these type of columns to impute it with unknown, because unknown gives a sense that okay, right now we are not aware that who is the director, who is the cast team with respect to any given movie or any given TV show, rather than writing a random mode value corresponding to it. So what we are doing over here is we are saying that take the director and fill NA, means it will take all the null values, nan values, and fill that value with unknown. So what we are doing over here, we're just filling it with unknown. So that's the whole point of it. So in this way, we will be able to handle these two columns pretty well. So if at this point of time, you will try to see that what is the missing value count with respect to these two columns, let me try to showcase you Netflix underscore df dot, if I will say is null dot sum, you will be able to observe that director is 0, cast is 0. Because now, wherever the missing values were there, we have handled it in an effective way and we have replaced those specific things with unknown so that it doesn't look wrong also, but it actually gives a right understanding in front of other person also who is looking onto the specific data that okay, we are not aware about this part. Let's say you are working in a customer's base data. I have observed this multiple times. You have a field called as email, which indicates the customer's mail. Now, sometimes people go for the imputation, and let's say ki you are doing randomly any specific imputation on top of it. Maybe you're trying to fetch a pattern corresponding to a first name and last name, and you're observing that let's say first name is Priya, last name is Bhatia. We can do a email missing value imputation with priya.bhatia@gmail.com. Is this a right way? The answer is no, because that specific way is completely wrong. I don't have that genuine email ID. The better idea could be if, let's say, corresponding to Priya Bhatia customer, email ID is missing, you can manage it by saying unknown. So that is the whole idea. So that data doesn't feel wrong also, and you will be able to handle the missing values also in a very appropriate way. Same thing is applicable over here. I hope it is clear. Now, this is the first part where we have handled the director and cast column. So I can write it as well, cast column. But still we have many more columns to handle. The next part will be where we have to handle the country column. Right? There also we have the lot of missing values. So what I have done over here, if you will try to see it in a clear way, basically country is a column where yes, you can take a mode value and you can just fill that with the way. Now over here we can see country.mode. It eventually gives me the mode of it. Why I have used zeroth index over here? This is very important to understand. Many people miss this point as well. Let's assume that you're working with any specific column. I'm giving you one simple example. Let's say you are having a country column. And inside that, you will be having the country name A, B, A, B, C, A, B. If let's say you are saying that I want to evaluate the mode of this, and I will replace, let's assume that there is a missing value after that. Okay, there's a missing value after that. And you are saying that I want to replace this missing value with the mode value. Okay. Now, when you say that I want to evaluate the mode value, for example, you have this Netflix DF, and you are mentioning inside this country as the column name, and you are saying dot mode. Do you know what this function will return to me? It will check what is the frequency of A. The answer will be 1, 2, 3. Okay. It will check what is the frequency of B specific country. The answer will be 3. It will check what is the frequency of C. The answer will be only 1. So in this case, I have two countries named A and B who is having the same frequency. So over here, I'll get the answer A and B because both of them are appropriate. Both of them are having a same frequency. So there is a clash and both of them will be returned by the Python program. But eventually, I cannot replace this missing value with both A and B. What I want is a single country name from which I can replace this missing value. That's why you will observe that whenever we are doing mode-based imputation, we always mention zeroth index. So that if, let's say, this code of mode will return me 2 answers or 3 answers having the same frequency, it will automatically take the first value as such. For example, in this case, it will take A and replace this with A. And that's the reason why we are writing over here zeroth index as well. I hope it makes sense to everyone. So over here, if I will just now copy the part of the code which we have written in that specific part to get a better understanding of it. So let me go back and let me try to copy this. So this is the one that we will be having, right? I hope now it is perfectly clear to everyone that why I have written this zeroth index corresponding to it. Mode will return the highest frequency, obviously. There could be a case that only a single answer will be returned because only one country has the highest frequency. But in case if we will be having multiple answers also as a mode because they have the same frequency, it will automatically return to me the zeroth index. That's the whole intuition about it. So in that context, we will be able to get the specific result. So I hope it is clear. So we will be able to handle it in an effective way. Perfect. What's the next part? Now, after handling 3 columns, okay, let me just showcase you a quick demo that it has actually handled well. So I can directly showcase you Netflix df dot is null dot sum. And over here, you will be able to observe that director, cast, and country now have 0 values. The only columns which are left is now date added, rating, and duration. Because their percentage is very, very less, I'm planning to drop it completely. So let's try to do next thing where we are trying to handle the remaining 3 columns, which is date added. Then we will be having a rating column, and then we will be having a duration column with us. Right? Over here, as we have discussed key, the percentage is very less, so let's drop it. Now we will be having this drop NA function. It will automatically check the missing values in these 3 columns and will drop it completely. I have used in place as true so that the changes will happen in the original data frame itself, which is Netflix DF. After this, do you remember there was an issue of data type inconsistency that we have discussed in our previous data understanding part? Data type inconsistency in the date added column. So now let's focus on working on it, right? Before that, I will just showcase you the final cleaned version of our data frame. So you can see is null dot sum, and over here you will be able to observe that each and every column has zeros values over here. So with this, we will be effectively able to handle all the missing values. Wherever required to drop, we have dropped it. Wherever required to impute, we have imputed as well. Now over here, the next part is to handle the inconsistencies in a date added column. So what we have done is we have done a conversion of this date added column to date time. So we have a function in pandas called as to underscore date time. We have used that. Over here you can see there's one parameter called as format is equals to fixed. This indicates that sometimes it could be a possibility that we will be having in the date part different formats. Maybe sometimes the date is being added in a, let's assume, the way we will usually see, for example 22/05 2026. Then it could be the case that that month will be first, followed by day, followed by year. It could be the case that it will be written as 22nd May 2026 and so on. So writing a date could be of multiple formats. So we're just saying that we don't know. There is a possibility that in our data it could be of mixed type. Tackle that and convert it into date time. And over here, there is a parameter called as day first. So you can see day first equals to false in PD. By the way, there is one more thing. Sometimes learners usually ask from me that, Priya, if let's say I will be having a confusion with respect to any given parameter, how can I check? So you can see that there is a proper documentation of every specific data frame that we will be having, not data frame, the module that we will be having. So you can see the parameter day first equals to false is the default behavior. What it tells the parser to treat ambiguous date strings. For example, if let's say we will be having this kind of a string, by prioritizing the month first. So it will check that, okay, over here, this is the month, followed by this is the date, followed by this is the year. Perfect. So over here, in this specific case, pandas will treat it as a Jan 5th. That's the only point. Month will be the priority. Perfect. Let me go back. So this is done. In this way, we will be able to handle the D-type inconsistency as well. Now, let's talk about that. Can we create any new column from the originally available features, which is also what we called as feature engineering, which can be eventually helpful for us in order to make the possible insights. And usually, whenever we will be having a date time specific type, we try to capture the years and months corresponding to it, because it will really helpful for us to create the plots and getting the insights corresponding to it. So that's what we have done over here. We have evaluated the year added and month added as well from that date added column. The simple way is dt.year will be able to extract from the date the year wala component. It will be able to extract the year from a date, and it will be able to extract the month specific portion from a given date. So this part will be done. And finally, they have done a proper verification and proper D-type checking once again. So this is kind of, you can say, final confirmation after handling, we can say, missing values and data type inconsistency. And now after this, we can just run this and we will be able to observe that it's quite fine. Okay, now we will be having 0 missing values. That's a good thing. And then we will be having its appropriate type as date time. Now the next part will be about doing a proper analysis of it. So over here, from this specific part, the next job will be to do a proper exploratory data analysis. So with this, we will be able to successfully completed our data cleaning and transformation journey. And now we have to focus towards doing a proper EDA of it. EDA means exploratory data analysis. Now in this journey, we will be doing it with 2 components. Either via univariate, means we will take one column at a time and we will effectively try to check the distribution of that specific column. We might try to check the, you can say, pie chart or histogram, depending upon what is the type of a given data. Apart from this, we can do a bivariate analysis as well. Univariate means that you're considering one variable at a time. And bivariate means you are considering two variables or two features at a time. So in this bivariate, we are trying to see the relationship among each other, these two features, maybe by creating a scatter plot, by creating a correlation heat map, and so on. So let's see, with respect to this specific data that we will be having, what specific plots could be a better idea. And obviously, whatever demonstrations I'm showcasing you, apart from this, you can also think that what else I can do apart from this, right? That's your task of the specific discussion. So over here, first of all, we have a column name called as type. So let's see the frequency count of each and every type. So we know in our D-type understanding, data understanding part, where I showcased you on Kaggle the meaning of each and every column, we have seen that the type could be of two in this specific case. One is movie, which is kind of a huge records are there with respect to that 6126 as comparable to TV shows, which is around 2664. D type is int, perfect. Now, whenever we want to see a distribution of how much percentage movie records belongs to with respect to TV show, better idea is to create the pie chart corresponding to it. So whenever we will be having two categories and we want to look for the distribution of it, for example, this is one of the example. Another example which is coming in my head is, for example, we will be having a column name called as gender, and you're doing any specific task where you want to see that how many percentage of males are there as comparable to female. So again, the pie chart plays a very interesting role over there. So we are just using a plt.py function. Plt again is an alias for matplotlib. Over there we can mention that, hey, I'm just looking for the type counts. Label is the index corresponding to it. And after that, we're just mentioning that what is the colors I'm looking for, what is the star angle, and over here, what is the percentage value, in what precision value we are looking for. So over here, we are just saying that after decimal, only one fraction value I just want to look for. So over here, I'm just mentioning the title, which is proportion of movies with respect to TV shows, and Y label is nothing, and we're just trying to showcase the plot. Now over here, based on the color, which is red and black, we are just trying to see that, okay, when we talk about movies, the proportion of movies is around 69.7% as comparable to TV show, which is clearly visible over here. So when we talk about this specific insight, we can say over here as an insight again that the Netflix library is highly dominated by movies, right? That's what we have observed, which make up roughly 69.7, means 70%, we can say, of the content in this specific data set. So that's the main insight we got. See, we can also share the insights from the above value underscore counts as well. But you can feel that when we talk about the numbers versus when we create the visuals corresponding to it like this, in our brain, these visuals gets a better understanding. Same thing happens when you share the insights to the clients as well. Better to showcase them with the appropriate visual. In that context, you should know that at what point of time which specific visual plays a important role. For example, let's say I usually say this specific thing, that let's say you are focusing on showcasing a trend. Let's say you are dealing with any specific column, maybe revenue. Revenue, is this increasing? Is this increasing or decreasing? Right? Is this increasing or decreasing from past few months? Better idea could be that you will always go ahead and create a line plot, because that is effectively demonstrates that line is going up or down. Accordingly, I mean, this is not something which is a mandatory rule. What I'm trying to showcase you and explaining you over here is my experience. I mean, that will be very impactful. Similarly, when you try to indicate the distribution of maybe 2 to maximum 3 categorical data points, for example, just now I have given you an example of gender, type, movie, and seasons that we will be having. So over here, pie chart plays a very interesting role. It will effectively demonstrate the percentage proportion. Similarly, if you want to see a distribution with respect to whether the data includes for any symmetric or a continuous data, I would say, distribution of any continuous data. In that context, better idea could be a histogram plot, right? It will effectively let you know that whether the distribution is symmetric or it will be skewed. So that is how usually we are doing also our work. So over here we can see that we have done a pie chart, because over here I just have two categories, TV show and movies. In future, let's say you will be having multiple categories. You will be having 5 or 7 categories. Then maybe it's not a good idea. Better to go for a bar chart, bar plot, right? Now let's move ahead. The next particular insight was how has the content added over the time, right? Now, obviously, to evaluate that, we need to group year added. Do you remember the feature engineering part that we have done? We want to group year added and the type, right? And over here, you can see based on the unique years that we have in a given data, which is 2008, 2009, 2010, 2011, till 2021 that we have in this specific data, we have the appropriate count of movie and the TV show. So we have just grouped our group by on our year added and then based on a different type, which is movie and the show. Over here, we are saying that fill NA as 0. So if let's say there is any missing value, missing entry, when we are doing a grouping, it could be replaced by a 0 entry. So in this way, you can see how basically as per the given year added, what is the effective count of movies in the TV show. So we can create a plot corresponding to it. And now because I just want to see the trend, again, time series analysis came into picture, right? You want to see a trend. Few minutes back, I have talked about revenue with respect to months. I have mentioned over here. So whenever in the x-axis you will be having maybe month, you will be having year, you will be having day, right? You want to analyze with respect to a given time, how is the trend going on. So in this specific use case, I just want to analyze the type, movie and TV show, with respect to the year added that we will be having. So over here, what are the insights we have? You can see when I run this line plot, over here, okay, we have to run the first part first. There is an issue. Why is that so? Let me check once again. Year added is not a part of a column. Let's go back to the feature engineering part. Okay, so by mistake, we have not run this specific block. Let's run this. And now when we come back below, it should be idly done. Yes, now we will be able to get the effective result. And now we can see the plot with respect to the same. So over here, you can see, because I have just used the marker as O, fig size as 14,8. Maybe we can just reduce it so that you can easily able to see the trend. You can just manipulate and play with this fig size. You can observe that over here, this orange indicates TV show. This movie indicates the blue line marker. I can just minimize my screen a bit. Now over here you can see, as soon as we are progressing with the upcoming years, TV shows somehow get a hike, but it's not that much as comparable to the movies, right? And how intuitively we will be able to get the idea now, right? So what is the possible insight over here? That, okay, as we are progressing from 2008 to 2020, both are actually evolving. The TV shows also, movies also, but if we have to compare both of them, we can say that movies have a great spike, especially in the year in between 2019. So we can write a proper insights now for the same. Let me expand now so that the insights will be properly visible to everyone. So let's write it down. We can say by separating movies and TV shows, we can clearly see that while both grew significantly from the year 2008 to 2020, right? The addition of movies, we can mention, actually accelerated dramatically, more dramatically, especially in the year 2019. It was a time nearby COVID, and that could be another reason for the same, right? So over here, we can mention that the growth in the, what we can say, TV shows as comparable to movies has been more steady, right? And there appears to be slight, we can say, shutdown in content additions in the year 2020 and 2021. So if you can see over here, in both the years, the graph is going down, whether we talk about TV shows or movies afterwards 2020. Now, again, this could be due to COVID as well. So we can say which could be due to the peak of COVID-19 at that time, right? Uh, which might affects the productions, or maybe we can say the data set could be incomplete for the latest years. So there could be two possibilities right now, right? Either the data is incomplete, or it could be the case that due to COVID-19, at that point of time, there was lesser production, and that could be the eventually reason for this downfall. Anyhow, let's go to the next specific part, where we will try to discuss about the most popular genre. Now, genre is something which is very, very important to determine, because a few people like maybe TV drama, few people like maybe romantic movies, few people might like the motivational movies. So what could be the genre over here? How can we get that? So over here, if you remember, we have one of the column called as listed in. For example, based on this US, there is a listed in under documentaries. South Africa, we have listed in under international TV shows, TV dramas, and TV mysteries, and so on. Now, what we will do over here is we will use something called as explode function over here. Now, what is the main purpose of this explode function? As the name itself says, explode. So, if let's say you will be having, for any given country, I'm giving you one simple example, or maybe for any given movie, there is movie A, and you will be having two genres for that specific movie, and it is written in under this listed in. You can do a split by with a comma, and let's assume in the original part you will be having it as drama, and let's assume another genre we can say is motivational. Okay, so as soon as you will use the explode function over here, so what will happen is it will try to give you two splits of it. Movie A, corresponding to that, in the genre we will be having drama, followed by again movie A, and under that we will be writing motivational. Something like this. I hope you're getting my point. So that's the same thing we have done. The main focus will be to determine maybe top 10 or 15 genres in this Netflix data. So what we can do, we can just use that explode function. So we have a genres column. Inside this, we have taken this listed in as a column name. We are converting it into string and then splitting it with a comma, because that is where comma segregations are there. We have seen that. And then we're using a explode function. Then we can see we will be having this genre specific column, which you can see documentaries. South Africa mein, we can have international TV shows. So in South Africa, we will be having international TV shows, TV dramas, TV mysteries. So you can see we can have three fields for that. South Africa, international TV shows, TV dramas, TV mysteries, and then US part is coming on. So that is how the explode function will work effectively. Now, once we get that, to determine the most popular genres, that's very easy now. We can just do a value underscore count so that we will be able to get the unique genre. And after that, we can just create a bar plot corresponding to it. Once we create that, you will be able to see, because we have just used the head as 15, so we will be able to get the top 15 genres over here, the count of it. And we can see international movies, dramas, comedies are the top ones, followed by, at the bottom ones, we will be having crime TV shows, kids TV, and docuseries. So that's the whole thing. I hope it is clear. Now, the next particular insight is we want to evaluate the distribution of content duration. See, when we talk about movies versus TV shows could have multiple episodes, whereas movies may be of duration 3 hours, uh, or let's say 2 hours. Right now, we have a shorter movies as comparable to the older movies. But anyhow, let's try to analyze it. So, what we have done over here, we have filtered the type as movie, and we just copied those specific data frame records inside this movie DF. Similarly, we have filtered the TV shows, and we effectively copied that and uh, created a new data frame altogether with the TV shows DF. Now, what we can do, obviously, if you try to see, let me do it in a separate header to showcase you one thing. Let me run this. Now, if I will try to showcase you how this movie's DF looks like, so you can see we will be having same columns only. It's just that in the type, now all the type belongs to movie only, starting from show ID till the very end, which is month edit. Now, again, when we talk about something called as TV shows DF, same thing will happen over here. So you can observe that in the type, all the TV shows will be visible to me. Now, what eventually we have done, we have taken duration in minutes with respect to the movie's DF duration. We can just replace a comma minute with a space, and we can convert it into type, because as far as I remember, duration was of object type. But ideally, when we're talking about minutes, it should be of int type. So that is what we have done. And similarly, we have cleaned and convert duration for TV shows as well. So maybe if you will be able to observe, let's go back. So when we go to the duration part, we can see over here we will be having 2 seasons. 2 seasons. So what we are doing over here, we are saying that, whenever you will be able to see space seasons, replace it with a space, first thing. And after this, there are two things. If 1 season and 2 seasons. So you can either have seasons or you will be having season. So we are trying to replace that seasons or season with the space, and then we're converting it into type. If you want to the specific replace operation, and directly if you will type as type of it, you will eventually get an error, because after this we will be having minute or season or seasons written on it. So first of all, we have to handle that effectively, then only the conversion will be possible. And that's what we have done over here. So over here we have replaced the minute, seasons, and season with a blank space, so that we will just have the number over there, and then we can convert it into int type. After this cleaning part, next part will be to create a corresponding plot, so that we can analyze the duration of movies versus the TV shows. So you can see, we can analyze it in a different way, because both of them have a different numbers. When we talk about TV show, we have a season distribution. It could be 1, 2, 3, and so on. When we have a movie duration, we have a minutes duration, right? So that is what we have done. So both of them have a different plot, because when we will be talking about duration, it will be in minutes. It's a continuous number. We can create a histogram corresponding to it. When we talk about TV shows, there will be count of seasons. We can maybe create a count plot corresponding to it. And that's what we have done over here. So for the first part, we have created a histogram plot. In the second part, we have tried to create a count plot corresponding to it. So eventually, this is the result that we are getting as the final insights over here. So over here, you will observe that when we talk about movie duration in terms of minutes, the kind of distribution which we will be eventually able to get over here. Let me try to minimize it further so that you can effectively able to see that. Can you see? So let me just open a pen over here to just effectively communicate these insights. Over here, one thing which I am observing, that somehow the peak is over here, right? So can I say that somehow within the range from here to maybe here, let's say 80 to 120 minutes, right? That is a sort of highest duration which I am getting in terms of the movie part. On the other hand, when I'm talking about TV shows, you can see the gap. The one season is kind count plot with respect to that. One season is having a very huge frequency as comparable to two, followed by three, four, five, and so on. So that is the critical insights that we have gained from here. So let's try to write it down in an appropriate way, and then maybe we can proceed further to the next specific analysis. So with respect to duration, let me maximize it again. I hope it is clear now. Let's write a proper insight. So what we got as an insight? We can say that the majority of the movies on Netflix are in the range, we can say between 80 and 120 minutes long, because that is where duration represents minutes over here, which is ideally we can say the standard as well, right, for any featured films, right? The second important insight that we have gained over here, let me write it as an header. This is the first insight we have gained. And the second insight is the vast majority of the TV shows on Netflix are short lived, because we just have a one season as a higher frequency. So we can say with most having only one season. One season. Now we can say that this could also reflect a strategy of producing many plots and only reviewing the most successful ones. Or maybe it could be the possibility that we are over here focusing on limited series as well. But eventually, based on our analysis, based on what exactly we have in our data, that's the insights that we have gained with respect to a movies part and with respect to the TV shows part. Perfect. Let's move ahead now. Over here, one more interesting thing which we have gained above, but I have not mentioned it. We can mention it as well. I think I have just now verbally mentioned that, but let's write it down in the above part. And that is about the genre. Although we can see and we have discussed, but I can write as an insight over here as well, that in terms of genre, we can see that international movies is the most common genre, highlighting highlighting the Netflix global content strategy. Right? Perfect. Now, let's move ahead to the next specific insight. Okay, before we will proceed ahead, I really hope that now you are getting a sense that at what point of time which specific plot is highly effective. And till so far, whatever plots I have written it down in terms of using a trend distribution of 2 3 categorical data points, bar plot when we have multiple categories, histogram when we will be having continuous data, we have already used as well. So perfect. Let's move further. Now the next part is to talk about where exactly the content came from. So you remember we have one column called as country, and we had handled the missing values as well. Now over here we can again, if let's say there is any given row where we will be having multiple countries, let's say the content is coming from USA, UK, and let's say India, with respect to any given uh, series. So maybe I can explore it further so that I will be having multiple records which indicates unique countries. And after that, what I can again do is I can just evaluate the top countries count. I can just rename the column names to the country name and the count corresponding to it. And now, because again, we want to evaluate with respect to each country, maybe what are the top 10 or 15 countries where exactly the content came from, we can again create a bar plot on top of it, just like the way we did above. Same strategy. So we have done this, explored. Once we have done the explored value underscore count. Reset index is used to reset the index further. Then we renamed it with the country and the count. So once we will try to print, maybe I can just showcase you what exactly we have under this top countries counts. So you will be able to see I'm getting the country name, the count corresponding to it. It means that on Netflix, maximum content is coming from US, followed by India, followed by UK. And over here, we can just create for the top 15 same bar plot. So you can see in the y-axis, I'm writing a unique country names we will be having, and in the x-axis, we will be having the count. So if we will try to observe over here, as per the insights, if we have to write it down. So in terms of insights, we can mention that the US eventually is by far the largest producer of the content available on Netflix, and followed by, you can say, India, which somehow we can say explains that why so many of the top actors were from India, right? Perfect. And eventually followed by UK also we can write. You can check and you can rewrite accordingly. Next part is about the evaluation of maturity ratings of the content. See, whatever be the features we have been given in this specific data, every feature plays a critical role. If that was not the scenario, maybe we can work on feature selection part where we might reduce the number of features. But because every feature is representing a unique information, we are taking each and every feature step by step. Now, when we talk about maturity ratings, what we can do is we can see what is the distribution of these content ratings on Netflix, and maybe which specific rating is having a higher count. So over here, you can see we can create a count plot where we will be having in the x-axis different ratings. By the way, eventually you can see the count as well using value underscore count. You'll get the distribution of it. But as you are aware of the fact that TVMA, I feel this is the matured part, having a highest frequency, followed by TV14, TVPG till UR. You can check the meaning of each and every rating at your end as well. But this is the count which we will be able to observe over here. So over here, as per the insights, what we can do. So we can mention that a large portion of the Netflix content aimed at mature audiences, right? With, we can say, TVMA, which indicates mature audience, and followed by TV14, which indicates a parents strongly cushioned, being the two most common ratings. That's it. Perfect. Now, in the next specific part, although in the starting also we have done feature engineering, where we tried to fetch the feature of year and the month, we can also evaluate the age on Netflix. What is the age of any given movie, any given TV show? How? Because we will be having a release year. And we also have a year added, which we have derived from the date added column. So we can get the age, and it could be possible that when we are doing a subtraction, we by mistake got a negative values as well. So we are just trying to filter out any potential errors by saying that just take only those specific records where the age will be more than equal to 0. So in this specific scenario, we will be able to get the content age, and we can check the distribution of content age with respect to the content added to the Netflix. So over here, we can check how older the content is and what's the frequency of it. So over here, you can see a large spike is at 0, right? A large spike is at 0. So let me again open my pen. We can clearly see over here, right? So you can see, let me just first of all erase these pointers. And you can see over here, mm, yeah, there is a spike. Maybe I'm facing some difficulty in terms of writing it down, but I hope that you can see over here. Let me do it in another way. Let me copy this plot, and over here I can write it on my writing pad. So you can see I'm talking about this specific area, right? So it indicates that significant amount of content is added in the same year as it's released, right? And this is, I can say, is the characteristics of Netflix as well. Followed by, you can see right tailed values available at 20, followed by 40. There is a sharp decline after that. So basically, we can say, as per the insight, we can say, as per the insight, that the large spike at 0 somehow indicates that the significant amount of content is being added in the same year. That's the reason. That's the reason. I mean, how you're evaluating the uh, age, you are checking the year added and the release year. So when it will become 0, when the year added and the release year will be in the same year. So it does indicate that the significant amount of content is being added in the same year itself, which I personally believe is the characteristics characteristics of the Netflix originals. However, as it's a right skewed, we can see there is a very long tail which we are observing, showing that Netflix also heavily invests in acquiring licensed content that can be decades old. In this way, it will be able to building a deep library of classic films and TV shows. Perfect. And this is how our univariate analysis will be over. Till so far, whatever insights we have gained, starting from the pie chart distribution, where we have seen almost 70% is that eventually contributed to movies, we have seen that we have done over here a univariate analysis only. Univariate analysis meaning, as I have mentioned, over here, till so far we have dealt with only one variable, or what I can say, only single feature at a time. But now we are uh, already finished with univariate, and we can eventually start with our multivariate analysis. Multivariate can also be bivariate, it could be 3 variables as well. So let's try to analyze multivariate analysis where we can involve multiple columns together. Okay. The first thing could be we can eventually check that we have multiple genres, whether we do have outliers available in those genres or not. And to effectively check that, we can create a box plot, right? Box plot is a very interesting plot which is especially useful to determine the outliers available. So eventually, if you see any data points above the upper whisker and below the lower whisker, those will be considered as an outliers. So over here, what we have done, we have just taken the top five records and the frequency of it. Then we have just filtered the genre of movie versus, we can say, if it is in a top genre, we're just copying it under this genre movies. Then the duration of it, same thing, we're just replacing it, the minute to empty space and converting it into int. After that, you can see with respect to the movie duration, we're just checking the outliers. So we will be having documentaries, followed by dramas, followed by international movies, followed by comedies. So over here, you can see if I will just try to ask from you that which specific genre has a higher outliers. So eventually, I can observe that it could be international movies, and as far as I remember, this was the top one as well. So, it could be possible that there are outliers available and we have to tackle them in an effective way. Perfect. So, as I have mentioned, let me explain you in a further better way. So, let me try to capture this specific plot. Acha, another way to capture these plots is you can also save these figures. So another way could be, let me just showcase you. We have a function in PLT called as plt.savefig. And over here you can say box plot and you can write any of the extension from where you want to save it. For example, maybe I just want to save it in the form of PNG. I will rerun this. And now when I check on my left side, you will be able to see there is a one PNG image available. I can download this image and I can save it for my future references. For example, I'll save it over here. And once I will be able to save it, I can simply go ahead and insert from that specific path a given image. So there, I'm just using a snipping tool, but definitely it's a good way where you can just directly access the image from here. Now over here, uh, you can see the below values are not properly visible. You have to enhance the fig size to make it like that. But right now we have decreased it so that you can easily able to see this specific part. You can see this is the values I'm talking about. They all are the outliers. So this is called as upper whisker, and this is eventually we call it as a lower whisker with respect to every plot I'm talking about. So it is being said that any specific plot, any specific data point which is below this lower whisker and which is above this upper whisker, all of them are the outliers. Always remember that. So there are two plots which are there. Usually we create box plot quite frequently, but violin plot is also one of them. Uh, Over here, just to make sure that whether the outliers are available or not in our given data, in our numeric data, we try to check it out. So over here, my question was ki which specific portion will have more outliers. So I still believe that this international movies might be the huge one, but we can directly check it out, exact outlier points also. We can just filter the records which are on top of the upper whisker and below on the lower whisker side. So these all are the outliers available in our given data. Perfect. It could be the highest number of outliers field as well. Perfect. Let's move further now. So from there we have understood how can we save the given image as well. Let's talk about the last part. Do you remember in the starting of the session I told you that we can create the different words in a given image? So how can we create it with the help of this word cloud? So let's try to see how it could be possible. But before that, if you want, we can write a proper insight for the same as well. So as per the given insights of the outliers, we can mention that international dramas, international movies, In fact, I'm still, I mean, these two I can write it down: dramas and international movies. Because exact number, when you filter the records, how many number of records you're getting, you'll get to know. I still feel international movies is the highest one, but you can eventually check it out by filtering it. We have done filtration a lot in the above part, so you can do it at your end, and you can just let me know what is the exact count of the number of outliers we have in drama specific part and international movies part. But yeah, these two we can consider have maybe more outliers, and somehow, if we will be able to see, they reflects the diverse film making styles around the world. Okay, perfect. Now let's come to this world cloud analysis. So over here we have a description column, if you remember, where with respect to every movie, every show, we have a description of it. So what we have done is we have just combined all the descriptions. So we have this join function. With the help of this, we can combine the descriptions together, and after that we can just mention the height and the width of our plot, a background color, and we can generate on that background a text of it with respect to a given description. So we are calling this word cloud function to do that. And then we are just trying to display that using I am sure this word cloud. So you can see the most common words in Netflix content description. We have mentioned the font size as well of those words. You can see whatever words you are able to see over here. Maybe let's decrease the size. This is the most common words which you can see: life, love, world, man, women, help, new, leave, and so on. So basically, over here, the insights are, you can see that the word cloud highlights the common themes and subject. Words like life, family, love, young, friends, world, they're more prominent, which suggests that much of the content revolves around human relationships, personal journeys. Action oriented words like find, secret, and new also appear more frequently in the given image. Perfect. And with this, our whole part of EDA on the Netflix data is over. Obviously, on top of it, you can do a lot of other stuffs. For example, we have seen on the above part the outlier observability. So, can we handle them? If yes, how should we handle them? If no, if let's say we take it as it is, so why is that so? What kind of algorithm should we use in future to make sure that these outliers won't get impacted much? So I'm just writing a final insights with respect to what we have done over here. What are the key findings of our work? Let's try to take it one by one. So you can see the key findings. The first part will be the content strategy. So we started from here. We have seen that it's a movie heavy, almost 70%. Second part is about global dominance, where we have seen US is the most uh, highest content producer, followed by India. Third part is about target audience. We have seen matured audience. Fourth part is about the content format and genre. We have seen dramas and comedies are universally popular, and the movie standard time is 90 to 20 minutes, while the TV shows only last for a single season. Common themes. At the very end, we have seen where description revolves around life, family, love, and discovery. What is the limitation? This data set, if you will be able to observe, is a snapshot in time and lacks viewership data. So let me just copy once again. Yeah. So you will be able to observe that when we talk about this specific data, this lacks the viewership data. Therefore, whatever analysis we have done, it is based on the supply of content and not about its demand or popularity. So over here, EDA provides a strong, multifaceted understanding of the composition and the evaluation of Netflix library. But obviously, if we try to explore more quality data, our insights will get better. Apart from this, what else we can do in the specific EDA on top of this specific data set itself? Please do let me know. Please try to explore that at your end. As I have mentioned, we have seen in our EDA journey that outlier solvability is there. How can we handle that? If we don't handle that, then obviously we have to think about better strategies in terms of machine learning algorithms. So please try to have a look onto it. And with that, I hope that you have really enjoyed this entire journey of doing a ED of Netflix data. And I hope that you have learned a lot. That, bye bye everyone, and I will see you all in my upcoming discussions.